Download this code from codegive.com, link in the description below. Deep dive into copying contents between buffered streams in Java. Copying data between streams is a fundamental operation in Java programming, especially when dealing with file I/O, network communication, and other data processing tasks. Bufferedinputstream and bufferedoutputstream are classes in the java.io package that enhance the efficiency of stream operations by providing buffering. This tutorial will comprehensively cover how to effectively copy content between bufferedinputstream and bufferedoutputstream in Java, including best practices, performance considerations, and error handling. 1. Understanding buffered streams. Before diving into the copying process, it's crucial to understand why buffered streams are essential. Input stream and output stream. These are the base abstract classes for reading and writing byte streams in Java. They provide basic functionalities for reading and writing individual bytes or arrays of bytes. Buffered input stream. This class adds a buffer to an existing input stream. When you read data from a buffered input stream, it reads a larger chunk of data into its internal buffer and provides bytes from the buffer to the caller. This reduces the number of calls to the underlying stream, example a file stream, improving performance. Buffered output stream. Similar to buffered input stream, this class adds a buffer to an output stream. When you write data to a buffered output stream, it stores the data in its internal buffer. The data is only written to the underlying stream, example a file stream, when the buffer is full, when you explicitly flush the buffer, or when the stream is closed. This also significantly reduces the number of calls to the underlying stream and enhances performance. Why use buffered streams? Using buffered input stream and buffered output stream generally improves the performance of I/O operations significantly, especially when dealing with disk-based files or network streams where each access to the underlying resource can be relatively slow. Without buffering, each read or write operation would directly interact with the slow underlying stream. Buffering reduces the frequency of these interactions by grouping multiple small reads or writes into larger, more efficient operations. 2. Basic copying implementation. The core logic for copying data from a buffered input stream to a buffered output stream is surprisingly simple: read data from the input stream, write it to the output stream, and repeat until the end of the input stream is reached. Here's a basic code example. Explanation ***. 1. Import java.io ***. This line imports all classes from the java.io package, which are necessary for file input/output operations. 2. Define source and destination files ***. The source file and destination file variables store the paths to the files you want to copy from and copy to, respectively. Important ***. Make sure the source file exists and the destination files directory has write permissions. If the destination file already exists, it will be overwritten by default. 3. Try with resources ***. The try with resources statement is a critical part of this code. It automatically closes the buffered input stream and buffered output stream when the try block finishes, either normally or due to an exception. This ensures that resources are properly released and prevents resource leaks, which can cause problems such as file corruption or program crashes. The try with resources statement only works with objects that implement the auto-closable interface, which both buffered input stream and buffered output stream do. 4. Create buffered streams ***. Buffered input stream bis equals new buffered input stream, new file input stream, source file, creates a buffered input stream that reads data from the source file. The file input stream creates the underlying stream that reads from the file, and buffered input stream adds the buffering functionality. Buffered output stream BOS equals new buffered output stream, new file output stream, destination file, creates a buffered output stream that writes data to the destination file. The file output stream creates the underlying stream that writes to the file, and buffered output stream provides the buffering. 5. Create buffer asterisk byte buffer equals new byte 4096, creates a byte array that will be used to store the data read from the buffered input stream. The size of the buffer, 4096 bytes in this case, or 4 KB, is a crucial factor in performance. Larger buffers can lead to fewer read/write operations, but excessively large buffers can consume too much memory. Experiment with different sizes to find the optimal balance for your specific use case. A multiple of 1024, example 1024, 2048, 4096, 8192, is commonly used, because it aligns well with typical block sizes used by operating systems and storage devices. 6. Read and write loop asterisk. Asterisk while, bytes read equals bis.read, buffer, equals -1, this loop reads data from the buffered input stream into the buffer. The bis.read, buffer, method attempts to read up to buffer.length bytes from the input stream and stores them in the buffer. The method returns the number of bytes actually read, or -1 if the end of the stream is reached. Asterisk boss.write, buffer, 0, bytes read, this line writes the data from the buffer to the buffered output stream. The boss.write, buffer, 0, bytes read, method writes bytes read bytes from the buffer, starting from index 0, to the output stream. It's crucial to use bytes read here because the last read operation might not fill the entire buffer if the end of the file is reached. 7. Success message asterisk system.out.println, file copied successfully, is printed if the file is copied without errors. 8. Error handling asterisk the catch, IO exception E, block catches any IO exception that may occur during the file copying process. It prints an error message to the console and also prints the stack trace using e.print stack trace. Printing the stack trace is essential for debugging, as it provides detailed information about the error, including the line of code where it occurred. 3. Improved copying with files.copy, Java 7 Plus. Java 7 introduced the java.neo.file.files class, which provides a more convenient and often more efficient way to copy files. Here's an example using files.copy. Explanation asterisk. 1. Import java.neo.file ** imports the necessary classes for NIO, new input/output, file operations. 2. Files.copy, method ** this method takes the source and destination paths as path objects, created using paths get, and a variable number of standard copy option arguments. *paths get, source file, converts the string source file into a path object representing the source file. *paths get, destination file, converts the string destination file into a path object representing the destination file. *standard copy option. Replace _existing, this is an optional parameter that specifies that if the destination file already exists, it should be replaced. If you don't provide this option, the copy operation will fail if the destination file already exists. *standard copy option. Copy _attributes, this option, if included, copies the file attributes from the source to the destination. Advantages of files.copy *. Simplicity *. The code is much shorter and easier to read. Efficiency * files.copy is often more efficient than the manual buffered input stream / buffered output stream approach because it can leverage underlying operating system optimizations for file copying. Atomic operations, potentially depending on the underlying file system, Files.copy may perform the copy operation atomically, meaning that the destination file is either completely copied or not copied at all, preventing partial file copies in case of errors. Options. The standard copy option enum provides options for handling existing files, copying attributes, and more. When to use files.copy versus bufferedinputstream/bufferedoutputstream *. Use files.copy when you simply need to copy a file from one location to another without needing to perform any data manipulation during the copying process. Use bufferedinputstream and bufferedoutputstream when you need more control over the copying process, such as applying transformations or filtering data during the copy. Monitoring the progress of the copy operation. Copying data between arbitrary streams, not just files. Operating on older Java versions before java.neo.file was introduced. 4. Advanced techniques and considerations. Buffer size optimization. The choice of buffer size can significantly impact performance. Experiment with different buffer sizes to find the optimal value for your specific environment and file sizes. Common values include 4 KB, 8 KB, 16 KB, and even larger, but the best size depends on the specific system and the nature of the data. If the data is being read from slow storage, a larger buffer might be beneficial. For very small files, a smaller buffer might be more efficient. Progress monitoring. If you need to monitor the progress of the copy operation, you can add code to track the number of bytes read and written. This can be useful for displaying a progress bar or logging the progress to a file. Character streams. If you're working with text files, consider using buffered reader and buffered writer instead of buffered input stream and buffered output stream. Character streams are designed for handling character data and provide automatic character encoding/decoding. Explicit flushing. While buffered output stream automatically flushes its buffer periodically, you might want to explicitly flush the buffer in certain situations, such as when you want to ensure that data is written to the underlying stream immediately. Call boss.flush to force the buffer to be written. However, excessive flushing can reduce performance, so use it judiciously. The try with resources automatically flushes the buffer when closing the stream, so often explicit flushing is unnecessary. Resource management. Crucial. Always ensure that you properly close your streams to release resources. The try with resources statement is the recommended way to handle this because it guarantees that the streams will be closed even if exceptions occur. Failing to close streams can lead to resource leaks, which can cause problems such as file corruption or program crashes. Error handling. Essential. Implement robust error handling to catch potential I/O exceptions that might occur during the copying process. Handle these exceptions gracefully, log error messages, and potentially retry the operation or notify the user. A good error handling strategy can prevent unexpected program termination and make your application more reliable. Closing order. When dealing with nested streams, example buffered input stream wrapping a file input stream, the order in which you close the streams matters. Close the outer streams first, example buffered input stream, and then the inner streams, example file input stream. The try with resources automatically handles the correct closing order. Encoding. When working with character streams, be aware of character encoding. Specify the encoding explicitly when creating the streams if necessary. For example, memory considerations. Be mindful of the amount of memory you're using, especially when working with very large files. Avoid reading the entire file into memory at once. Use buffered streams and smaller buffer sizes to process the data in chunks. If you are handling extremely large files, consider using memory-mapped files from java.neo.channels.filechannel, which can allow you to work with portions of a file as if they were in memory without actually loading the entire file. 5. Complete example with error handling and progress monitoring. This example combines best practices for copying data between buffered streams, including error handling, progress monitoring, and resource management. Key improvements **** separate copy file method **** the copying logic is encapsulated in a separate method, making the code more modular and reusable. The method also throws IO exception, allowing the calling method, main in this case, to handle the exception if desired. File not found exception handling ** added specific handling for file not found exception for more informative error messages. The exception is rethrown to allow main to handle or log the exception as needed. Console output ** the console progress updates now use \r, carriage return, to overwrite the previous progress line, providing a cleaner progress indicator. A new line character is printed after the copying is complete to ensure the final progress is visible. Rethrowing exceptions ** the copy file method throws IO exception, allowing the calling method, main in this case, to handle the exception. This allows for more flexible error handling. For example, the main method might choose to retry the copy operation or display a different error message to the user. Increased buffer size ** the buffer size has been increased to 8192 bytes, 8 KB, which can improve performance for larger files. 6. Summary. Copying data between bufferedinputstream and bufferedoutputstream is a fundamental task in Java programming. By using buffered streams, you can significantly improve the performance of I/O operations. Remember to choose an appropriate buffer size, handle errors gracefully, and always close your streams to prevent resource leaks. Consider using files.copy for simpler file copying scenarios, but retain the knowledge of how to manually copy with buffered streams for more complex situations where you need greater control over the process. The robust example provided gives you a great starting point for your own projects that require efficient and reliable stream copying. Always test your code thoroughly with different file sizes and types to ensure it performs as expected and handles edge cases gracefully.